Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge, and the problem is the path sum 2. Given the root of the binary tree and an integer target sum, return all root to leaf paths where the sum of the node values in the path equals target sum. Each path should be returned as a list of node values, not node references. We have to return a list, not the node references. The root to leaf path is a path starting from the root and ending at any leaf node. A leaf is a node with no children. Okay, fine. This is the given tree. As you can see that the path from root to leaf 5 plus 4, 9, 9 plus 11, 20, 20 plus 2, 22, which is the target sum given. So since it is equal, we have to return a list containing return a list which is 5, 4, 11, 2. And then there's another path 5, 8, 4, 5, which is also equal to target sum 22. So we have to return that list as well, 5, 8, 4, 5. So how can we approach this problem? Obviously there are multiple ways of traversing the tree. We are going to use one such way. For that, how we can do is to have a vector we want to carry a data structure which is a data structure that is going to have the elements in our vector, so that when we reach the leaf we will be comparing the sum and the target sum. If it is equal to the target, then we can put that particular data structure into our result. So for that we have to carry a result also. Result is nothing but the vector of vector int, and the data structure is nothing but I'm saying the vector of int. This is going to carry the data structure, carry the vector, and I also need a sum variable, or I can use this targets variable, so that whenever I reach the leaf node, whenever I reach leaf node, what I will be doing is I will be comparing the target. If my target becomes 0, target is 0, then I will put my data structure into my resultant. Don't push back of this data structure. So this is simple base case. So how we can do this? Okay, when I'm starting at this root node, whenever I come inside this function, I will write a pseudocode. Whenever I come inside the recursive function, I'm going to do a traversal. First I will see whether the nodes value, if my nodes value is greater less than or equal to my target. If my nodes value is less than or equal to target, then I can subtract my target and I will move it to left. Whenever I move to left, I want to put this 5 into my data structure. So what I will do is if my nodes value is less than or equal to target, then I will put my current value, pushback of nodes value into my data structure and move it to left. Solve function of root of left. My target will reduce by this node value, and my data structure is also getting passed and resultant is also passed. Okay. If my nodes value is greater than or equal to target, I cannot reduce my target at all. So I'm not doing anything, any stuffs. So after going and surfing through its left, I will again see whether my, now what will happen, we will give a dry run. My target is 22. So first of all, 5 is less than or equal to target. So 22 will be reduced by 5 will be reduced from 22 and it will become 17. Now I will be in this node 4. So 4 is less than or equal to 17. So 4 less than 17 minus 4. So I will check now. Now the target will become 13. Now 11 is also less than or equal to 13. So I can reduce 11 as well from the target. 13 minus 11, which is 2. So now when I go to its left, it is a leaf node. If it is a leaf node, I will be checking this if condition. I will not be coming here at all. So I will be checking this leaf condition. So what I should do is, I should not say that target is equal to 0. I should say if my target is equal to my nodes value. If my target is equal to my nodes value, then I will put this. Then I will put that particular node value into my data structure, and then I will put data structure dot pushback of my node value. Then I will put my data structure into my resultant, and then data structure dot pop back. Why so? Whenever I return back, the particular node value should be popped out from the data structure. So 7 anyway 7 is not equal to target value. This will not be executed, and then it is going to just return. Okay. Next, what is the case? Next, while going back, I want to move it to right. So this recursive function, I will just copy and paste, and I will move it to right. And again in right, what will happen? 11, 13 minus 11, it will move it to right. And in this recursive function, the target is equal to the node value. You can see this is my target at that recursive call. 2 is equal to the node value, so that I will push that 2 into my data structure, and I will put it into my result, and data structure dot pop back is happened. Now 2 is popped back, and now the data structure will be containing 5 4 11. Now whenever I come back, I should pop back the particular element, or else I will be retaining this 11 into my vector itself. So now my 11 is popped back, again my 4 is popped back since there is no right, and again 5, before 5 is popping back, I will make a recursive call to its right. So while doing this, I will be having the target to be 17. So whenever this recursive call is happened, I will be seeing whether my 8 is less than or equal to 17. Yes, it is less than. So 17 minus 8, which is 9. And 8 is also pushed into my vector data structure. Then I will go to its left. Since 13 is greater than 9, this will not get executed, it will come back. And 8's right. Since 4 is less than or equal to 9, so 4 will be getting reduced, and I will also push 4 into my data structure, and then I will move it to left. Whenever I move it to left, since it is a leaf node, I will compare with this condition. As you can see that 5, next my target is 5, target is 5 is equal to this node value, this leaf node value. I will put the 5 into the data structure, and then I will put the result, and then I will pop back, and then I will return, as you can see that. So whenever I come back, I will do a recursive call again. As you can see that 5 1 minus 1 is also less than next recursive call, 1 is the leaf node, and as you can see that target 5 is not equal to the node value 1. I will not put that path. So hope I gave a dry run. Let us quickly code this approach. Vector of vector int, I need, this is my result, and I should also have a current data structure, and I will call the recursive function. Before that, return this. I will call the recursive function solve. In that solve, what I'm doing is, I will pass the root then target sum, then my data structure and result. Hope this should be fine. And the private function, I'm going to have a void function solve tree node star root int target and vector int. This is a data structure. This is my vector carrying vector int, sorry, data structure and vector of vector int res. This will be my resultant vector. And what I will be doing is, first I want to check whether it is a leaf node. How I can check that if it is a leaf node? Before whether it is a leaf node, I should check for one case my root should not be null. If my root is null, I will just return. Or else if it is a leaf node, if it is a leaf node, how I can check? If not of root of left and if my not of root of right, then this is a leaf node. If this is a leaf node, I want to check if my target is equal to my root of val. If my target is equal to my root of val, data structure dot pushback of root of val, then the data structure should be pushed into my resultant. Then data structure should be pop the last value, pop back, then just return. If this is not the case, I want to check for one condition. If my root of val is less than or equal to my target. If this is so, then what I can do is I can push data structure dot push back of my root of val into my data structure, and then I want to go for left and right recursive call. Root of left target will be reduced by root of val, then the data structure is passed, result is passed. Just copy paste the recursive call and write this passed. Right is passed. So what I have done here is now I have made the right recursive call. After going and coming back, I should just pop back the last value, which is root of pop back. That's it. I can just call it pop back. So hope this should run. Let us run our code and see. Yeah, it is getting accepted. Let us run the code for the other test cases as well. Yeah, it gets accepted. Superb. Now we can submit our code. Okay, we get a wrong answer. Why so? Yes, actually we have done a big blunder mistake. Actually this minus 5 is my target and minus 2 is less than or equal to target. So if it will not go into this if condition is at all. So what we can do is, if this is having a negative values, if the tree is having a negative values, this will not go to this condition at all. So we can just eliminate that if condition and code. We can also add another value if my target is less than 0. If my target, I can add here itself, if my root is null, or if my target is less than 0, then I can just return. Or else, no, we should not do this target, or else it will not pass in negative case. Yeah. Because I should form either case, right? So now we can just run this code. If this is having a wrong value, then it will definitely happen. Yes. Now let us submit the code. Superb, it got accepted. Okay. Hope you like this solution. I have just missed a minor case. If the tree is having a negative value, then we have to not add that condition, because the node's value can be less than or equal to the target. Either way it can be. So the other things or other steps are all same. So this is my resultant vector, this is my data structure. I am calling the recursive function root with target sum, data structure and resultant. If my root is null, return. If this is a leaf node, I am just seeing whether the target is equal to the root value. If so, I will put it to my data structure and resultant and then pop back and return. Or else I will push that root value into my data structure and then I will go for its left and right and then just pop back. I will take out from that data structure. Hope you like this solution. Let me know in the comments. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.